All right, today we are diving deep, and I mean really deep, into one of the most incredible transformation stories in the history of life on Earth. We're talking about the evolution of the whale. It's an epic journey, 50 million years in the making, that takes us from solid ground into the deepest parts of the ocean.
Okay, so let's start with a question that seems pretty simple on the surface, but the answer unlocks this entire story. Is a whale a fish? I mean, they live in the water, they swim around, they're huge, they sure look like fish. But the truth is so much cooler.
So what's the verdict? Well, it's not even a close call. Whales are mammals, through and through. They don't have gills, they have lungs, and have to come up for air. They're warm-blooded, just like us. They give live birth and nurse their babies with milk. And here's a dead giveaway: the way they swim. A fish's tail goes side to side. A whale's tail, it moves up and down. That's a classic mammalian movement, a leftover from when their ancestors used to run on land.
But wait a second. If a whale is a mammal, that means its ancestors must have lived on land. So how in the world does a land animal end up back in the ocean? I mean, that's just wild. And this is where our story gets really interesting.
So if we want to play detective and find the whale's ancient relatives, we're not going to find them near sharks or tuna. The family tree is way more surprising. A whale's closest living relatives are actually land animals like cows and, get this, the hippopotamus. Yeah, the hippo. This tells us that to find the origin of whales, we don't look in the ancient oceans. We have to look on land. So let's go meet the pioneers. The fossil record gives us this incredible, almost step-by-step picture of the animals that made this huge leap, the ones that bridge the gap between shore and sea. These are the very first walking whales. And what's amazing is how fast this all happened, evolutionarily speaking. It all kicks off around 50 million years ago with our first creature, Pakicetus. Just 2 million years later, boom, we get Ambulocetus, the walking whale. And only a million years after that, Rhodocetus is already much more at home in the water. It's an incredibly rapid transformation. Our story really starts with this animal, Pakicetus. Picture a four-legged, kind of wolf-sized creature that lived around the edges of rivers and lakes. You'd never, ever look at it and think whale. But paleontologists found one critical clue hiding in its skull: its inner ear bone. It was uniquely shaped, just like that of a modern whale, an adaptation that's perfect for hearing underwater. So even though it lived on land, its body was already getting ready for a whole different world. The journey had begun. All right, next up in our lineup is Ambulocetus, and its name literally means walking whale. And that's exactly what it was. It could walk, probably a bit clumsily, on land, but it was also a powerful swimmer. You can just imagine it, right? Hunting like a modern crocodile, ambushing prey from the water's edge. This thing was the perfect bridge between two worlds.
Then we get to Rhodocetus. Now this one was even more aquatic. Its legs were already starting to look a lot more like flippers. But here's the really key innovation. Its nostrils were no longer at the tip of its snout. They had started this slow march backward, up its head. And you are looking at the very beginning of the evolution of the modern whale's blowhole. How cool is that?
So once these ancestors fully committed to the ocean, once they became full-time water dwellers, something amazing happened. The constraints of living on land, like gravity, just disappeared. And that unlocked the potential for them to become true giants. Meet Basilosaurus. By about 40 million years ago, this creature was fully aquatic. It had this long, almost snake-like body, stretching up to 60 feet, with powerful flippers and a tail made for swimming. But it was still carrying a secret from its past. Tiny, completely useless hind legs, complete with little knees and toes that weren't even connected to its spine anymore.
This table just puts it all into perspective. Follow the timeline with me. We start with Pakicetus, maybe 6 feet long, the size of a wolf. A few million years later, Ambulocetus and Rhodocetus are around 10 feet long, maybe like a small crocodile. But look what happens once they become fully aquatic with Basilosaurus. The size just explodes to 60 feet. And that trend just keeps on going, right up to the nearly 100-foot blue whale we see today. It's crystal clear. Leaving land for the ocean unlocked their potential for massive scale.
Which, of course, brings us to the obvious question. Why? What was it about living in the ocean that allowed and even encouraged whales to evolve to such an immense size? Well, it turns out there were some huge advantages to being a giant in the ocean. For starters, a bigger body is like wearing a thicker coat. It's just much better for staying warm in cold water. And while gravity punishes size on land, the ocean's buoyancy basically makes you weightless, so you can get massive without being crushed. Plus, when you're that big, you're pretty much predator-proof, and you can travel huge distances way more efficiently to find food. It was a winning strategy all around.
So just how big did they end up getting? The modern blue whale can reach 30 meters in length.
To put that into perspective for you, that is longer than a professional basketball court from end to end. Just incredible.
And what about their weight? Well, that can be up to 199 tons.
That is the same weight as 33 elephants, all put together. It is, without a doubt, the single largest animal to have ever lived on our planet. And this was all made possible by that one evolutionary leap, moving from the land into the sea.
But there's one last piece of evidence. A final, beautiful clue to their land-based past that every single whale and dolphin carries with them today. It's like a ghost in their biological machine.
The clue lies in something called vestigial structures. And that sounds like a fancy term, but really all it means is biological echoes from the past. Leftover body parts that served a purpose in a distant ancestor, but are no longer needed today.
And here it is. This is the mic drop. Deep inside the body of a modern whale, floating completely disconnected from its skeleton, are tiny pelvic bones. These are the actual remnants of the legs their ancestors used to walk on land millions of years ago. Just think about that for a second. They are carrying the blueprint for legs that their lineage hasn't possessed for over 40 million years. It's the ultimate proof of their evolutionary journey, written directly into their own anatomy.
So when you really think about it, whales aren't just ocean creatures that happen to be a bit like mammals. They are land mammals that made the most audacious move imaginable. They didn't start in the ocean. They walked right into it. It really makes you wonder, doesn't it? What other echoes of ancient worlds, what other incredible transformations are hiding in plain sight in the animals we see all around us every day? Thanks for joining us.